Have a look on the conditional probability versus total probability. This term always comes in your mind, that what is the difference between conditional probability as well as total probabilities. Let us see one by one. We will discuss conditional probabilities. Number one point about conditional probability is that it is the chance of an event happen given that another event already occurred. Okay, already occurred or already happened, already seen, already known, etc. These can be the words for that. You can recognize by the statement itself that this is the question or statement regarding conditional probability. And in conditional probability, there is two events, and one event will be act as the condition on the second event, or second event may be act as a condition on the first event. So this is the story of two events only. Okay, it takes the condition 2 by 2, means at a time it will consider two events. Okay, in continuation it may be added various conditional probabilities together or maybe multiplied together, but at a time it will handle two events. Okay, another, let us come to this total probability. It is the overall chance of an event by, this is chance of an event, this is overall, means total chance of an event by adding up its conditional probabilities across all possible and separate scenarios. Okay, means total probability is, in case of total probability, there is one event which will be imposed by various conditions, and those conditions are separate, means among those conditions there is no intersection. Their intersection is phi, but their union will be your sample space of the event. Okay, we will clarify this point more when we go through the second point. Come to this second point, denoted by probability of A given B. A given B means probability of event A when B has already occurred. It shrinks the sample space event to event B only, means you can see that B A when B is already happened, means we will not discuss now the sample space in this case. We will discuss the event B only. Okay, if B has happened, then what is the probability of happening of the event A in that scenario? Now here total probability says it is denoted by PA, means total probability of event A, means total probability of event A across all possibilities who are separate and mutually exclusive for a sample space. Okay, means total probability of event A for all possibilities, all the conditions who are separate and mutually exclusive for a sample space, means their intersection is phi and their union will give you the sample space. Once again I am repeating the same thing and it will be clear from the below diagram. Okay, very much clear. Now formula for conditional probability is probability of A given B is probability of A intersection B divided by probability of the event B. Means if you pay attention on this diagram, there is a sample space under which two events, suppose A and B. Okay, if somebody asks that probability of the event A when B has already occurred, its value will be obtained by the probability of A intersection B divided by probability of B. Means this probability you will find out, so this by the number of elements in the sample space and whole divided by probability of B, means the element, all those elements of B divided by the sample space elements. Clear? This is the meaning of probability of A given B. Similarly, probability of B given A means A has already happened. Under that you have to check for this intersection portion, and you find the probability of this intersection and divide it by the probability of this. So probability of B intersection A divided by probability of A. Clear? This is the conditional probability. Now you can see here this B A intersection B and probability of B intersection A both are same. Yes or no? So if these two are same, then we can say the probability of A given B into B is equal to probability B given A into A, PA. Yes, so by combining, since PA intersection B or P of B intersection A same, so by that logic, probability of A given B into PB will be same as the probability of B given A into PA. And I should write it here that both are equal to probability of A intersection B or probability of B intersection A. Okay, clear? Now come to this total probability. Total probability formula is PA. It will be this is your diagram A, and these are the conditions. Means under these conditions, how A is happening. So B1 intersection A. This is B. This portion is B2 intersection A. This portion is B3 intersection A. This portion is B4 intersection A. Yes or no? And this B1, B2, B3, B4, both, all the four conditions are mutually exclusive, means nothing is common. I have written over here. Their intersection will give you nothing. Fine, that's it. But their union will give you a sample space. This is the mandatory condition for a total probability, to calculate the total probability. Okay, in this scenario only we calculate the total probability using this formula. Okay, what is this formula? Probability of A means I am saying that probability of A intersection B1. You can see this. Next time I am saying A intersection B2 means this whole will come. Next time I am saying intersection B3, this whole will come. Next time I am saying this whole, isn't it? Do you agree with this? There is no problem. Now this can be written as in the form of conditional probability. Conditional probability, see here, PA intersection B can be written as P given B of the probability A into PB, PA by B into PB. So here also we will do the same thing, that PA intersection B1 I will write PA given B1 into PB1. Okay. Similarly for the second one, PA given B2 into B2 plus PA given B3 into B3 plus PA given B4 into B4. And if you have n number of such partitions given, this formula will extend up to the n, and in that case we will say the formula like this. We will say, always used to say that probability, total probability will be given by summation I is equal to 1 to k P of A Bi into PBI. That you have understood now? Why we are doing this summation? Because we are going to add. How much time we will add? Then I will vary from 1 to k. Here I, in my example, I am using 4 partitions, so I will vary from 1 to 4, that I have written over here. Is this clear, this formula? Now example you can go through for this conditional probability. Means two events and one event has happened, then you have to find the probability of the first event. Chance that a student pass a test A given he studied all night. This is the another event B. Means what is the chance of a student to pass? What is the given condition? He studied all night. This type of situations will come under the conditional probability. Here one more example. Overall chance that a student pass a test B given he studied all night, one event, or he did not study all night, means both case he can pass, yes or no. It is not necessary that one day before you are studying all night and you will be pass or fail. You cannot decide that based on you can only find the probabilities. So probability can be there. If he did not study well, then also he can pass, yes or no. So when we have more than one condition imposed, in that case we find the total probability of the event, okay, with given conditions, so many. And in case of conditional probability, we find the probability of the event with only one given condition. This is the major difference, or this is the difference. That's all. You have one condition, here more than one condition. In one condition, you have to find A given B, and in more than one condition, then you have to find PA. Okay, and given B1, given B2, you have to separately calculate. Okay, so finally we can say that probability of A given B is probability of A intersection B upon probability of B, and probability of A will be given as probability of A intersection B1, A intersection B2 in this case. So probability of A given B1 into probability of B1 plus probability of A given B2 into probability of B2. Okay, means if these data you know, you can find out the formula, the conditional probability or the total probability. Clear? Now, real world example. Suppose question could be like this: what is the probability that it will rain? This is the event rain, given that already cloudy weather. This is another event. Okay, this is the condition. Means in case of cloudy weather, may rain, may not rain, it can be there, but you have to find what is the probability that it will rain given that weather is cloudy. So if the data is available, you can calculate it. Now for this total probability, the example is like this: what is the overall probability that flight will be delayed given that weather is cloudy or stormy or clear sky? Means all these cases may imply that flight will be delayed. Okay, due to clear sky also, if the traffic is not clear in the sky, then this weather condition of clear sky will not help for flight to be on time, because they have to manage the traffic in the air. For cloudy weather also, they have to take care of that. Stormy weather also, they have to take care of that. That how much risk they can take, but they should not take risk. But if you want to, some data is given, you can find the probability, yes or no. So this is the theoretical explanation of all the conditional and total probabilities. In the next video, we will see the examples related with these. Thank you.